Okay, let's take a look at problem number 5. Problem number 5 is a little bit different from 1 and 3 in that there's an extra descriptor in here. Find two consecutive even integers whose sum is 26. All right, so this is going to be a little bit different from what we did before. So we're looking for two integers. So we're going to start out the same way. We're going to say let n equal the first integer or the smallest integer. So again, let me start with 6 as we've been doing. So we're going to say that that's our n. And then when it says consecutive even integers, right, when we're talking about even integers, instead of skip counting by ones like we did up here when we talked about it, for consecutive even integers, we're skip counting to just name the even integers. So that would be 0, 2, 4, 6, 8, 10, and so forth. All right, so they're consecutive even because they're the two even numbers that are side by side. So 2 and 4 would be consecutive even integers. 4 and 6 would be consecutive even integers. If they said 3 consecutive integers, we could do 4, 6, and 8. All right, so they just have to be side by side even integers. All right. Okay, so if we're talking about 6, then the next number would be 8. So again, we're thinking, how would we describe 8 relative to 6 or relative to n? It would be 2 bigger, so n plus 2. Think about it. When you're looking at this list of even integers here, they always skip count by 2. To get from 0 to 2, we add 2. To get from 2 to 4, we add 2. To get from 4 to 6, we add 2, and so forth. So they're always 2 apart. So that's why we would say that the first integer is n, but then the next one is 2 bigger than that. We skipped right over the odd integer. So this is the next integer. All right, there's only 2 of them, so we're going to stop there. And then it says that they add to 26. So n plus 2 has to equal 26. I combine like terms, I get 2n, whoops. Sorry, 2n plus 2 equals 26. I subtract 2 from both sides, and I get 2n equals 24. 2n equals 24, I divide both sides by 2, and I get n equals 12. So that means my first integer, my smallest integer, was 12, and then my next integer has to be 2 greater than that, which is going to be 14, right? So then we think about it. 2, 12, and 14 add up to 26. Yes, they do. So the two integers are 12 and 14. Okay, one more, problem 9. This is the one that messes everyone up. All right. First of all, it says find 3 consecutive odd integers. So 3, we just have to think of 3 of them. The consecutive part is fine. The odd part is what messes everybody up, and we'll talk about that. So first, let's just write down let n equal the smallest integer. All right, then let's think about this for odd. So let's start with 7. All right, and we'll call that n. What would be the next odd integer? All right, so that would be 9. And then the next odd integer after that would be 11. And then if we kept going, 13 and 15 and so forth. So if we're relating the 9 to the 7 or to the n, we would say that this is 2 more than 7, because again, every time we go from an odd integer to another odd integer, we still go 2. It doesn't matter that these are odd and that's even. The distance between all odd integers is 2, right? Same thing with even. It's just that we're always skipping over that value in between. So we're skipping over 8 here. We're skipping over 10 here. So to get from 7 to 9, it's 2 jumps. We hop to 8 and just kind of skip that, and then we go to 9. So even though these are odd numbers, we still call this n plus 2. because it's 2 away from the odd number that was here. Then for 11, it's 2 more than this one or 4 more than this one. So we're going to call this n plus 4. Again, the fact that these are even and we're talking about odd integers really messes with people. Don't let it mess with your head. Just remember that all odd integers are 2 apart. All right, so then the next one would be n plus 2 equals the middle integer. And n plus 4 would be the largest integer. All right, if you need to watch that part again, just to kind of wrap your head around it as to why these are the labels for those 3 integers, please do. Okay, so it tells us that the sum is 87, so I'm going to add all 3 of these, n plus n plus 2 plus n plus 4 equals 87. I collect like terms, so I get 3n plus 6 equals 87. I get 3n plus 6 equals 87, and I get to subtract 6 from both sides. So 3n equals 81. And then I divide both sides by 3, and I end up with n equals 27. All right, so our smallest integer is 27. Our middle one is 2 bigger than that, so our n plus 2 is going to be 29. And our next one after that is going to be 31. So let's just check to make sure that these add up to 87. Actually, let me do this. 9 and 1 is 10, plus 7 is 17. So put down the 7, carry the 1. 3, 4, 5, 6, 7, 8. Yeah, it works. So the answer to this would be the integers are 27, 29, and 31. Okay? All right, that's it. Thanks.